Welcome to the course Energy Resources, Economics and Sustainability. In the last class, we have been discussing the problem of the global climate change or GCC, or we also know it with the names like global warming, climate change, and we tried to understand how this problem is very difficult from the problems that were seen earlier resulting from the use of energy sources. The problems were lead, sulfur oxides or acid rain, the ozone depletion, and these problems could be solved to a certain extent because of the policy measures that were taken. Whereas the global climate change provides us a very different challenge. We'll continue with the same discussion where we keep on try to understand like what are the major challenges posed by the global climate change, and we'll also start the discussion what could be the possible mitigation measures, what are the steps that could be adopted in the future that can help us tackle this big problem that stands in front all of us. So let's start with a discussion where we try to understand first the difference between weather and climate. Often we see that these terms are used interchangeably, but there is a difference in the meaning that is annotated to weather and climate. Weather basically refers to a short-term product of the different interactions that happen between the sun, the different kinds of biospheres, atmosphere, hydrosphere, and the different types of vegetation, mountains, and the different kinds of geographies. It's basically a short-term phenomena dealing with what is the temperature that is going to be in the next few days, whether we are going to get a precipitation, what are the likely wind speeds going to be, are we going to get enough sunlight or not, and to some extent weather is predictable in the short term. All of us have been used to using apps in our mobile phone which predict whether it is going to rain today or not, what are the chances of rain, are we going to experience a sunny day or not, is it going to be cloudy, what is the temperature that I can expect in the daytime as well as the night time, what could be the typical wind speeds. So these are some things that are predicted to a good extent, and also we have the different weather channels predicting that this for different cities on the TVs, as well as like every one of us uses these features on the mobile phones. If I talk about the long term, maybe months or years, weather is not a very predictable thing. We can only predict these kinds of things for the short term, maybe few days or a week at max. But if we talk about months and years, such kind of predictions are not very accurate. Comparing this with climate, climate is more of a long term phenomena. It can also be said that it is like the average weather taken over a period of several decades, and climate is something that we might be able to predict over the long run. We can say with a certain degree of accuracy that the summers maybe 10 years down the time are going to be hotter than the winters. This is the likely temperature that we can experience in the summers. This could be the likely average rainfall. So this is most likely giving us the average values that we would be able to experience in the future years, given the prediction by the different kinds of global climatic models. There are a lot of them, and based on different assumptions they give in different kinds of predictions. And we have one such prediction that given the rise in the temperature in the past, we can expect the temperature rise to reach so and so extent. An example is given in the figure at the bottom, like we can expect how the temperature is going to rise, the average temperature is going to rise in the future because of the prevailing conditions. So climate, yes, it is able to be predicted over a long run, and we have seen the different kinds of climatic models have predicted with a good confidence level, more than 95%, that a great deal of temperature rise that is being experienced by the world today is because of the fossil fuel uses. It's because of the greenhouse gases that result from the combustion of fossil fuels, which mainly are attributed to coal, natural gas and crude used in different energy applications. And this CO2 and allied gases, because of the greenhouse gas effect, are able to capture the radiations from that rise from the Earth's surface, and slowly and steadily they are warming up the Earth's surface. What we are not very certain about is the exact magnitude of the temperature rise that might happen in the few years, but the different type of climatic models are pretty much on the same page when it comes that a rise of maybe 2 degrees Celsius or something similar is expected to have major catastrophic events. in the future, and this type of effect could be triggered by an atmospheric concentration of CO2 if that exists the 450 ppm level. So the current concentration of CO2 is somewhere around 410 ppm parts per million, but it is likely to increase in the future with the rise in the CO2. Also, we understand that climate is something that can be predicted for the future, and even a small change in this climate could have drastic effects on the vegetation patterns, on the lifestyle of the people, on the way the different economies work. Whereas a change in the weather, maybe a few degrees here and there or a few centimeters of rainfall here and there, might not make a drastic difference. So climate is something that we are much more worried about than weather. A change in the average weather, average climate by 2 degrees Celsius can have a very good effect on the population. It can lead to the submergence of many big cities under the water. It can lead to the disappearance of polar ice caps. It can also change the vegetation patterns. Some of the areas which are known for their productivity of different types of grains might turn into deserts, and there could be other way around as well. The deserts might receive good amount of rainfall and might become suitable for cultivation in the future. So just to give you an example, this is one type of prediction like by one particular type of global climatic model. It shows you like currently we are at a certain level of global GHG emissions in terms of gigatons of CO2 per year, and based upon the trajectory that we achieve or the trajectory that we adopt, we might reach different levels of a temperature rise, which could vary from anywhere from 1.5 degrees Celsius to 3 degrees Celsius. So based upon how good we can formulate policies for the reduction of the global CO2 emissions, the future climate change that happens maybe in the span of the next 80 years or so could be very different. So if we talk about what are going to be the likely impacts of global climate change, so the major impacts could be clubbed into three. One would be the melting of the polar ice caps. So we have a good amount of surface of Earth that is covered by ice. A majority of it lies at the two poles, the Arctic and the Antarctic, and also we have the mountains covered with ice. The advantage of the surface covered with ice is that it is able to reflect more than 90% of the insolation that we receive from the sun. So that is good in the point of that we are not capturing much heat. But if there is a rise in the temperature of the earth, which we have been experiencing, many of these ice caps might melt, and because of the melting, the surface below the ice caps, which is normally rock and darker in color, might get exposed, and these kind of surfaces in turn would have a lower reflectivity of the sunlight, which might lead to more absorption of sunlight, which further initiates more temperature rise. So it's like a feedback loop that is going to exaggerate the temperature rise if it is not checked. Further, another problem that is linked to this kind of melting would be the sea level rise. All the ice, when it melts, is ultimately going to enter into the seas, and it has been estimated that if a major part of the western Atlantic ice is to melt, the sea rise could be of the tune of around 5 meters as compared to the present level. And if there was, if all the ice that is there on the earth was to be melted, it would raise the sea level to almost 60 meters above the present level, and that could have huge implications. Further, the sea level rise happens due to two reasons. One is the melting of the ice, and further because of the global temperature rise, we also have the expansion of the water bodies, because the volume would, as a function of temperature, as we have increasing the temperature, the volume occupied by a certain quantity of water would also increase, and that is also a reason why we are experiencing a great fear. We are in great fear that a temperature rise might lead to drastic effects in the future in the form of sea level rise. Further, these kinds of impacts can also lead to regional climate changes, and the prediction of these kinds of changes is not very accurate to say, because this depends on many different phenomena. But it is estimated that the temperature is going to play a major role, and it has been suggested that some parts of the world might become very different from what they look to today. There could be rainforests turning into deserts and vice versa. It is going to change the vegetation pattern, and with this is also linked the way people interact with each other, the way economic policies are formed, the way businesses are performing, and it could have significant influence on the different supply chains, be it the food supply chain or the different raw materials. So this the effects could be very drastic in the future. So just to give you an example, this is one figure which gives you the areas which are the most vulnerable to the sea level rise. So on the bottom what you see is the level of sea that is rising above the level of the 1990s, and a 1 meter rise could be a problem for Indian cities, like specifically the major cities like Bombay or Calcutta. And then we also have major parts of the world or the major cities of the world along the coastline, and there could be issue. And if there is a rise to up till 80 meters or so, which is not like expected to happen in the near future, but still it can lead to submergence of great parts of the world. To gain a better perspective, maybe I'll just take you to a simple tool. So this is just a simple tool. There are many such tools available on the internet, so it's just for the understanding. So here we are focusing on Mumbai, and the color in the red basically shows the areas of Mumbai which becomes vulnerable to a rise in water levels. So if I select a water level of maybe 3.8 meters, we can see great deal of Mumbai getting submerged. So given that it is the economic capital of India, a great part of the GDP of the country arise from this one particular city, this could have many drastic consequences. We can also zoom out and see the effect on the whole country. So it's not only the Mumbai that is going to submerge, but the effect is also going to be felt in cities like Kolkata, which is again a major metro city. We can see a great part of the state of West Bengal and Orissa being lost, and something similar can be seen in the south as well. Another major metro in the form of Chennai is going to be affected by that. And if we see India as a country, like it might not appear to be drastic, but we can see that 3 major cities, 3 major metros would bear the blunt of sea level rise in India. Further, let me also show you, like this was recently in the news that Indonesia, which is again a major country in Southeast Asia, is now considering moving its capital from Jakarta to Borneo. Again, one of the major reasons for this shift is like because of the rising sea levels, and it is expected by the year 2050 a great deal of city would be underwater. So they don't want to take any chances, and they want to start as soon as possible. So this the aim of shifting the capital from one city to another city has already been initiated. And further reiterating the earlier point, that if you again analyze the global population, and this is again one of the figures that we have discussed in the past as well, you will see a great deal of the global population lives around the coast. So you can see the China, even in India, the US, a great deal of population. So it is almost estimated that almost 75% of the world population, or more than 70% of the world's population, lives within 60 meters of any coastline. So that makes the situation even worrisome, that we have a huge number of people living near the coastline, and there are different reasons for that. And they all become vulnerable to a sea level rise, which could have drastic consequences in the future. Some of the countries like Maldives or other island countries might cease to exist if there is a considerable sea level rise that happens in the future. So again, these are some predictions for India, how the local climate is going to change in the future. So this is the wet belt temperature prediction for the 30 years, and given the like we can see there is a significant rise in the average temperature, which is a part of the climate given the different scenarios. So no matter if we are going for a low emission scenario or a high emission scenario, there is going to be a temperature rise that we would be experiencing in India, and that could lead to different changes, the change in the weather pattern, the change in the monsoons. We wouldn't go into the details, but like given our agriculture is a lot dependent upon the rainfall, this could have significant consequences for us as a country. Now we have got some understanding of the problem. Now let us also spend some time in discussing what could be the possible mitigation measures. What are the different mitigation measures that have been suggested by the different types of scientific communities, and let us try to analyze the pros and cons of each. So before that, like there could be some other effects. There could be some other effects of climate change which have been told. It could be the change in the global water cycle as well as the precipitation. There could be change in the how and the quantity of rainfall that we receive. Another major consequence that we are currently facing is the intensity of the tropical storms, cyclones and hurricanes. The intensity and the number of incidents is on a rise if we compare to the history, and much of it is attributed to the change in the climatic conditions that we are experiencing. Further, a great intake of CO2 by the oceans is also expected to increase the acidification or the acidity of the oceans, which would again affect the aquatic ecosystems. There might be a change in the food chain, which basically feeds the different kinds of organisms. And again, the increased temperatures of the atmospheric like CO2 also exaggerate the release of CO2 in the atmosphere. So, this is basically a feed forward loop in which greater the amount of CO2, the processes are tuned in such a way that it only accelerates the CO2 that would be coming in the future. So, that basically exaggerates the problem. And with this, we have tried to understand like what could be the possible consequences of CO2 that is going to the atmosphere. But let us also try to understand what could be the different mitigation measures. And these mitigation measures are suggested by the different scientific communities. And let us go further and try to understand what could be the advantages and drawbacks of some of these measures. So, let us try to understand or educate ourselves with some of the key mitigation measures that have been suggested to tackle the problem of global climate change. So, one of the first measures that have been suggested that came in early, why do not we reduce the energy consumption itself? Our energy consumption has been rising exponentially in the past few decades. Let us go for the low hanging fruit. Energy consumption is the key source. Energy consumption entails use of fossil fuels. Fossil fuels entail release of the CO2 in the atmosphere. So, why do not we go with more energy efficient pathways, which is the least disruptive, least expensive and the most feasible alternate, and it could help us like both have saving in the environment as well as the cost saving as well, because the money, it would have its monetary benefits as well. So, let us try to do a simple example to understand what could how we can bring in energy efficiency into being. So, let us take the example of a delivery agent who is working for any of the companies, an example could be Amazon or something similar. So, the delivery agent would is expected to travel around 30,000 kilometers a year, and we are expecting that the so called agent is currently using a light truck. The mileage could be around 12 kilometers a liter. We would want to estimate how much CO2 does this truck produce every year, and it is also suggested that what if the salesperson would want to substitute this truck with a smaller car, maybe a hatchback, and the efficient or the and for this car the mileage could be 25 kilometers. So, let us reduce to 25. So, 25 kilometers per liter, and we would want to understand how many liters of gasoline will be saved and what could be eventually reduction in CO2 emissions. And we may also want to assume that gasoline is composed only of octane, whereas it has many hydrocarbons. Let us for this particular calculation, let us say it is only octane, and the density of gasoline is also known to us as 770 kgs per meter cube of gasoline. So, let us go to the whiteboard and try to do the simple calculation. So, first let us go with the petrol use. So, we are traveling around 30,000 kilometers, and the mileage is almost, for the small truck, is 12 kilometers per liter. So, we do this division and we come to the conclusion that this would be consuming almost 2500 liters of petrol per year. The density of petrol is also known to us in the form of rho, and this is given to us at 770 kg per meter cube. I can multiply this with the above figure, and the petrol use would come out to be roughly 925. kgs per year. I can also divide this with the molecular weight of octane, and this would be roughly 16.8 kilomoles of fuel that would be used. Now octane, we understand, can be given by the formula C8H18. This would eventually combine with 12.5 moles of O2 or oxygen and eventually lead to production of 8 moles of CO2 plus 9 moles of water. Or I can also say 114 kgs of octane, which is the molecular weight of octane, is going to lead to 8 into 44 kg, which is the molecular weight of CO2, and eventually this would come out to be 352 kgs of CO2 getting produced. So if I was to estimate the total amount of CO2 that is getting produced, this will be equal to the fuel that was being used, 1925 into 352, which is the CO2, and divided by 114 in the form of kgs, and the answer would be 5944 kgs. So a typical truck, small truck riding around 30,000 kilometers is going to release almost 6 tons of CO2 in a year, which is not very much. And if I am going to replace this vehicle with a smaller car, and I am taking the mileage of a smaller car to be 25 kilometers per liter. So we can see the use of petrol. This would be the 30,000 kilometers, again divided by 25 kilometers per liter, and this would be coming around to be around 1200 liters of fuel. Compared to earlier we were using 1925, so we are using good amount of petrol, and the reduction, earlier we were using almost double, 2500 liters, so the reduction I would say is almost 1300 liters, and we can also estimate the amount of CO2 that is getting reduced, and this reduction is also equivalent to 1000 kgs or so. So if I talk about, okay, maybe I can say 101 kg, just multiply that with the density. If I talk about the CO2 reduction that would be coming from this change, this would be 1001 kgs of fuel that is saved multiplied by 352 divided by 114, and this would be roughly around 3091 kgs per CO2. So this small change of going to a more efficient vehicle can help us save around 3 tons of CO2 for a year, and this is just for one salesman. And not only this is also going to be accompanied by a saving in the cost. So we can also assume that the typical petrol cost at the filling station could be around rupees 100 a liter, and the cost saving that the salesperson could incur would be around 100 into 1001, so roughly 1 lakh rupees a year. So there could be some significant cost saving that also comes in with the increase of the efficiency of the process. But again, this might limit the carrying capacity of that particular salesperson. The amount of goods he or she can carry becomes limited as well. So there's another trade-off there. So we can see we can make some amount of carbon reduction if we go towards much more efficient processes, but given the extent of CO2 emission that we are experiencing, this might not be able to make a worthwhile dent. So if we go back to the slides, Then another pathway that could be adopted would be substitution of the coal based power plants with nuclear or hydro based production technologies, which are much more which have been used in the past as well, and there has been a good amount of experience. So for nuclear, we can say that it has been used in the developed world for the past 60 years or so. The experience is very good. Like there have been technologies that have been there around. There have been major incidents like the Chernobyl or the Fukushima disaster, and that is something that has created a perception of a negative perception for the nuclear fuels, and this is something that needs to be well addressed if these kinds of technologies are to be propagated in the future. So we have had major environmental disasters resulting from these kinds of power plants, although the probability is quite less, but these kinds of incidents have happened, and they could happen in the future. So we would have to look towards the long term safety, as well as we would also have to look at the storage of the nuclear waste that is created. So this nuclear waste needs to be stored, and it needs to be stored for quite a time in the future, so that it doesn't come in contact with the living organisms, and that is again a big issue. And let us try to understand the applicability of these kinds of alternates with the help of another example. So let us suggest that we would want to suggest or retire 5 old coal power plants that have been into operation for quite few years, and they were in totality they were providing a power range of around 2000 megawatt. We would want to now replace these power plants by 2000 megawatt nuclear power plants. The average efficiency of the older plants I am assuming to be around 34.5%. Let us determine the amount of CO2 emission that they were producing, and given that we will take an assumption that all of the energy is coming from coal, and the coal is composed of 100% carbon. So let us, and we also aware that the heat of combustion of carbon is approximately 32,000 kilojoules per kg. Again, I am considering a high grade coal to be used in this particular case. So let us go to the whiteboard again. So let us try to understand that the output power that I am looking for in this case is equal to 2000 megawatt, and the corresponding input power that I would have to put in would be 2000 megawatt divided by 0.345. So this is the typical efficiency of the coal based power plants that I have assumed, and this number would come around to be 5797 megawatt. If I talk about in the energy terms, the input energy that I would need would be this 5797 into 60 seconds, 60 minutes, 24 hours, and 365 days, assuming that this plant is operating throughout the year. And the input energy would be roughly 182.8 into 10 to power 9 megajoules per year. So this is the amount of energy that I would require. And I also know the heat of combustion of carbon. And this is known to me as 32,800 kilojoules per kg. And I divide the two values, I divide the total energy by the heat of combustion of carbon, and this would give me the coal that would be used, and this would come around to be around 5.57 into 10 to power 6 tons of coal. And assuming that coal is 100% carbon, I can calculate the amount of CO2 that would release, and the CO2 that would be released would come out to be around 20.43 million tons, and this is per year. So you can see that a change in one of the major power producing plant to a technology that would not have carbon emission can help save a lot of a lot amount of CO2, because these are the point sources of CO2 where the CO2 is concentrated and the production happens at a very fast pace. So and these kinds of changes could have much greater relevance as compared to the efficiency change, where the use would be widespread, much more decentralized and varied. And if we go towards a technology that could be like nuclear or renewable, we could have enough savings in terms of the carbon dioxide release on an yearly level. So these we have discussed two major mitigation measures. What is the efficiency increase, and the other is updating the technology to nuclear or maybe hydro. We'll continue on with this discussion in the next class as well, where we are going to discuss some other measures like carbon sequestration or the carbon utilization, growing or more trees, seeding of carbon dioxide with oceans, or it could be that we direct air capture. And we'll try to understand how does those methodologies compare to these one. With this, we end today's class. Thank you.